So the next thing that you got to know in probability is independent dependent events. Okay, and it's very simple. So before we do that, let's just look at this question. Okay, so we have a coin that's tossed and a die is rolled. List the possible outcomes. Do you guys remember what to draw if a die is rolled?
Oh, table.
Table, not a tree diagram. Good. So I'm going to draw a table like this. Okay. What goes in here?
The die.
Yep, the die.
Oh, 1, 2, 3.
That's right. So all the die numbers, I'm going to write it here. 1, 2, 3, 4. And a coin. That's right. Okay.
Sir, would it matter if the
No, it doesn't matter. If you write the numbers here and head and tail here, is that what you're asking?
Yeah.
Yeah, it doesn't matter. It's just better this way because if you write the other way around, it takes up more space downwards. So what am I writing here again? H1,
H2,
and I'm just going to keep going. Okay, looking at these outcomes, what is the probability of getting a head and an even number? So how many combinations are there here which has a head and an even number together?
3 out of 12.
Yeah, so we got H and 2, yeah, H and 4, and H and 6, yeah, because that's a head and an even number together. Yeah, so that's 1, 2, 3 out of how many altogether?
12.
Yep, which is
1, 4.
yeah. Yeah. Now, this is the question that I want to go through. Are the two events dependent or independent? So what that means is, if I toss a coin, does that affect or determine what number I'm going to roll on a die? So for example, if I get a head on a coin, does that mean I'm going to get an even number on a die? No. They're independent. It has nothing to do with each other. So that's your answer, independent. So when there's an event and that has nothing to do with the outcome of another event, that's independent. So for another example, let's say I have a normal die and after that I'm going to choose a marble from a bag. Okay? If I roll a certain number here, does that mean I'm going to choose a certain marble in here? No, they're two separate objects. So the answer is independent. Okay? These two are two separate things. It has nothing to do with each other. Okay? How about this one? A coin is tossed 3 times. Each of the 3 coin tosses independent or dependent. So what they're saying is, let's say I flick a head on my first coin. Does that mean on my second toss I'm going to get a certain outcome? No, that's each and every separate events, right? So what's my answer?
Independent.
Independent. When it has nothing to do with each other, it's independent. All right. I'm going to show you an example here where it is a dependent event, okay? So let's look at a similar example that we did last lesson. So a bag contains 4 blue, yeah, and 3 green cards. So 2 cards are chosen. Like I said, the most important word after that sentence is? Without replacement, okay? So the first question, as usual, let's draw a tree diagram showing all outcomes with the numbers. So for my first pick, how many branches am I going to draw based on the number of different colors there are in the bag?
2.
2, yeah? Because one color is blue. Yeah, that's right. If there were 3 different colors, then there'll be 3 branches. Okay? Right, now let's assign the probability. How many blue cards are there?
4 out of 7.
4 out of 7, yep. How many green cards?
3 out of 7.
3 out of 7, good. Now let's do the second branch. Let's say I chose blue. Pop. I still have 2 colors to choose from, B and G, but how many blue cards are there now?
3 out of 6.
3 out of 6, good. How many green cards?
3 out of 6.
3 out of 6 as well. Okay? Now let's go back to the beginning. Let's say this time I chose a green card. Pop. I still have blue or green to choose from, but this time how many blue cards do I have?
2 out of 7.
Blue card,
4
yeah.
out of 6.
Yep, 4. Okay. Are the 2 events independent or dependent? Now what you'll notice, in my first pick, the probability of me picking a blue card is 4 out of 7, but the probability of me picking the blue card again is 3 out of 6. Notice how it's not the same number as my first pick, and that's because in this case, I've chosen a blue card in the beginning, which has now changed the number of blue cards in my second pick. So as you can see, my second pick is dependent on what I choose in the beginning. So it is dependent, okay? So what I'm trying to say is, when the question says without replacement, it's always dependent, okay? Now I'm going to have a look at a scenario if the question said with replacement. Now, remember from the previous video, if the question says with replacement, the number of blue marbles for my second pick, it's the same as my first pick, because remember, you're putting the card back in and then choosing another card out. So it's exactly the same as the beginning. So the chance of me picking a green card is still 3 out of 7. Nothing changes, as you can see in the picture. Okay. Number of blue cards, still 4 out of 7. And number of green cards, 3 out of 7. Okay. So when it's with replacement, the numbers don't change. Okay. So that means the events are now independent. Okay. Because for my second pick, because I'm putting the card back in to originally how it was, okay, it's not dependent on what I pick in the beginning. They're separate because I'm starting all over again, okay? So basically what I'm trying to say is if the question is with replacement, the answer is independent, okay? Because the numbers don't change, as you can see here, all right?